Hi scholars, today we're going to talk about rational expressions and equations, and in particular we're going to model with rational equations. So what's a rational equation? Well, it could be something like 1 over x plus 1 over x plus 2 equals 7. Okay, for example, equation means there's an equal sign, and rational just means that there will be some values that can be expressed as rational expressions, right, in this equation. So let's take a look at a few examples. So first example, working alone, I can paint a room in 7 hours, and you can paint a room in 5 hours. So it takes us h hours and m minutes to paint a room if we work together. So we want to know how long, right? What are the values of h and m? We want to know if we work together, how long would it take us? Now you say, oh, that's an easy question. If it takes me 7 hours, it takes you 5 hours, we're working together. So together means plus. Together it should take us 12 hours, and we're done, right? Well, no. We can't really do that, because does it make sense that if it takes you alone 5 hours and then I come to help, it's going to take us together more time? Nah, it should take us less time, right? So this is an example where the answer, our initial gut inclination, doesn't really make sense. So we can sort of make better sense of this if we view this as a rate, okay? So when we say that I can paint a room in 7 hours, we're saying that I have a rate of number of rooms per, right, per number of hours, okay? And this is a sort of simple way of making a rate. And now let's model my work and let's model your work. So I can paint one room in 7 hours. So I can paint one room in 7 hours, and you can paint one room in 5 hours. And the question is, how long would it take us? Well, this is the number of hours, right, is in the numerator or the denominator position. How long would it take us if we work together? So here's where the together comes in, right? We're adding. We're saying if we work together, how long would it take us to paint one room? Okay, so now we have this thing, which is a rational equation. Now we could solve this in a few different ways, right? One way is we could find common denominators. So I could look and say 7 and 5, and I have an x. So actually the common denominator they could all share is 35x, right? So I could, if I wanted to, let's just do this very quickly, I could say that 1/7, I could say let's multiply it by 5x over 5x, plus I have my 1/5 here, I want to multiply it by 7x over 7x, right? And this allows us to have a common denominator, and this would end up being 1 over x, and I'm going to multiply this just by 35 over 35, right? And if we did all that, you'd see that all of the denominators would be the same. So you could do it that way, right? And then if all the denominators are the same, then you can compare the numerators, right? You can sort of just do the math on the numerators. However, this would be a few steps. There's a lot of opportunity to make mistakes. So we're going to show you a nice, good trick to use when you have rational expressions or equations that you're trying to solve. And the trick is called to multiply across, to multiply by the least common denominator, okay? So this is a great trick when dealing with rational equations. So in this case, we see that we have a 7, we have a 5, we have an x. So in this case, the LCD is going to equal 35x, right? It's the least common denominator among all these things. So what we're going to do is we're going to multiply. Here, let's do it in a different color. So we know that this is the LCD is 35x, okay? So what we're going to do is we're going to take this whole equation and multiply everything by 35x. Now the question is, can we do that? Well, sure we can, right? If I have an equation, I can multiply each side of the equation by the same thing. I'm not really changing anything, right? Now notice what happens when I multiply everything by the LCD. Well, this first term, 1/7 times 35x, is just going to be 5x. The next term, 1/5 times 35x, is just going to be 7x. And this final term is just going to be 35. Now look at that equation. Isn't that so nice, right? It brings us back to middle school math. So we can easily solve that. We get 12x equals to 35, and our final answer is x equals 35 over 12 hours. However, we want to find out how many hours and how many minutes, right? So if I look at this, 35 over 12, I want to say, well, is it over 2 hours? It is. right? 24 over 12. Is it over 3 hours? It's not, right? It would be, if it's 36 over 12, it would be 3 hours. So I can rewrite this as 24 over 12, right, plus 11 over 12. And this right here is my 2 hours. So this right here is 2 hours. So I know that H equals 2, right? And now all I have to do now is to convert 11 over 12 hours into minutes equals how many minutes, right? And I could do this in a few different ways. I could multiply, right, by 60 over 1, which is the conversion factor or whatever, but I can also reason proportionally, right? I'm really asking, I know that there are 60 minutes, right, in 1 hour. So the question is, how many 12s are there in 60? So here, let's just actually do it in a new page. So we have 11/12 hours, right? And I know that this is how many hours. I know that there are 60 minutes, right, in 1 hour. And so how many minutes, right, if I'm just using proportional relationship, what number would go up here, right? So this is times 5, so we're going to do times 5. And we end up with 55 over 60, right? So since this ratio is equal to this ratio, we know that the answer is 55 minutes here. So if we go back to our previous problem, we say, what is the value of H? Well, that's the 2 hours. And then 11/12 of an hour is actually equal to 55 minutes. So M equals 55. So this is our answer. Let's take a look at another example. Example number 2. Solve for C in terms of A and B. So this is a question that is, again, we have a rational equation. Here's our equation. And we want to solve for one variable in terms of the other ones, right? In terms of just means that we're going to do a lot of work and we're going to end up with C equals something with A in it, with maybe some numbers, and something with B in it, right? So C is on one side and A and B are on the other side. That's what this question means. And again, we're going to use our handy formula, or our handy trick of multiplying across by the LCD. So multiply by the LCD, and we ask ourselves, what is the LCD? Well, in this case, the common factor, right, or the common denominator, if there's a factor of A, a factor of B, a factor of C, the LCD is just A, B, C. This whole thing, the product of A times B times C. Now let's see what happens when we do that. Okay, so we're going to multiply, again, the entire equation by, here I'll write it on this side, by A times B times C, and let's see. On the next step, right here, the A's cancel, right? So when I do this multiplication here, I end up with 5BC equals, I have 3 over B times ABC. It's going to be 3AC, right? In that case, the B's cancel, right? B cancels with that B. And then minus 2 over C times ABC is just 2AB. Now notice what this trick did for me, right? Just like in the last problem. What it did is it got rid of all of these pesky denominators that make solving equations a little difficult, right? In one step, you get rid of them all, and you end up with sort of a simpler equation that it's a little bit easier to solve. So again, let's go back and look at what we want to do. Well, we want to solve for C, right, in terms of the other things. So first step is, let me get C's all on one side of the equation. So I'm going to do that. I'm going to do that by adding 2AB to each side of the equation. And then I'm going to subtract 5BC from each side of the equation. And this is just to be comfortable with my signs, so I have all these positive signs. I end up with 3AC minus 5BC, right, because these terms cancel. And over here, all of that is going to be equal to 2AB. Now notice, why did I do that? Well, I did that, again, because we wanted to solve for C, and this allows us to get C on one side of the equation, right? Before, in the original equation, C was on two sides of the equation, right? So now we have it all on one side. And now the next step is very nice. I notice I have a common factor of C, so I can actually pull it out. And if I pull it out, what do I have left? I have 3A minus 5B. Okay, nothing to it. Still equals to 2AB. And finally, final step, to get C all alone by itself, I just divide by the quantity 3A minus 5B. And final answer is that C equals 2AB over 3A minus 5B. B. This is your final answer. Now, it may look ugly. However, that's okay, right? And it does answer the question. We solve C in terms of A and B. Let's take a look at one more example. Example number 3. There are 150 jelly beans in a bag, and 60% are red, and 40% are blue. Okay. How many blue jelly beans would you need to add in order to end up with an equal number of red and blue jelly beans? So we have a bag. There's some jelly beans that are in different colors, and we want to know how many blue ones can we add in order for, instead of there being 60% and 40%, for there to be 50% and 50%, right? That's what equal numbers mean. Equal numbers would mean they'd be 50% of each. Okay, so we can do this in a couple different ways. So let's try it this way. If there's 150 jelly beans and 40% are blue, how many are blue? Well, 40% of 150. Now we know how to do that, right, from last semester. 40% of 150 is the same thing as 0.4 times 150. And plug it in the calculator, do some mental math, you end up with 60. So we know that we have 60 blue jelly beans right now. So currently, we have 60 out of blue jelly beans out of the total, so we keep the total in black, which is 150. This is currently what we have. That's my 40% that are blue, okay? We want to add something. We want to add blue jelly beans to this mix. So we're going to add something. And we want, when we add something, the result to be that this ratio, right, is 50%. We want there to be 50% jelly beans, right? Currently there's 40% blue. We want there to be 50% blue. So we want all this to equal, well, I could write it as 1/2, right? That's okay. Or I could write it as 0.5, right? Each one of those represents 50%, or right? So let's do it as 1/2 just for the heck of it. That's fine. Either way will work. And so here we have our equation. Not careful. We're not entirely done here, because remember, if I'm adding, right, some blue jelly beans, right? That's what I'm doing here. I'm adding some blue jelly beans right here. I'm also adding to the total number of jelly beans, right? I can't just add some blue jelly beans and have it not increase the total. So in fact, this is the setup right here. This right here is the setup of the equation. This is the appropriate model of this particular situation. And right, the question is, how many would we need to add? We're being asked, solve for x, okay? So again, this whole thing is representing a ratio of blue jelly beans to the total number, right? So this ratio represents that, and this ratio represents that, right? Okay, so we can solve this. Well, we can cross multiply. That's pretty easy. And right now it's just that we end up with arithmetic. So we have 2 times 60 plus x equals 150 plus x. We end up getting 120 plus 2x, okay, equals 150 plus x, we end up x equals 30. So the answer is that we need to add 30 jelly beans, blue jelly beans. And if we do, then they'll be half and half, blue and red. Now we want to ask ourselves, does this make sense? Well, how could we do it? Let's check, right? If I plug in 30 into this original equation, right? So we'll just do it all in the same color. So if I have 60 plus 30 over 150 plus 30, I end up with 90 over 180. And yeah, indeed, 90 over 180 is 1/2 or 50%. Have a great week.